Welcome to this session. In this session, let us try to understand how the network protocols evolved. In the last session, we have seen why we need network protocol, right? So let us revise some of the points which we discussed in that. In the earliest days of computer networking, right, machines are from the person from the different countries altogether, right? So this is different country, this is different country, and they were trying to talk to each other and couldn't able to communicate because they talks in a different language. So everything is actually a chaos because nobody understand what other people says. And one more problem is if you try to send a packet, send a data for example, right? So you are sending this data into the packets. Now you are not sure in the destination, if you send it in 1, 2, 3 in sequence, you are not sure that whether you will receive in the same sequence or you will receive only first or third or you will receive only third. That guarantee also was not there. So there is no protocol, there is nothing which will make sure that whatever you send received as is, right? So there was nothing. So all this chaos, right? It made clear that computer need a set of standard rules. They need one rule book. And everybody should follow that rule book and send the messages according to that rule book. That's how your early first protocol got defined. Right? And that early protocol set the stage for the network evolution. So if you see the timeline of evolution of network protocol, then it looks like this. So initially the internet, if you understand internet, right, if you have read about internet, then it was first started with ARPANET. It's a defense agency of US, right? So they are the first one who brought the concept of internet, and they are also the first one who started networking. Right. So they were initially using host to host protocol. That was a base which was started in 1970s. Then they realized it has some problems and all. Then slowly SMTP got evolved. That simple email transfer protocol. Then again there were some problems which they understand. Then TCP/IP got evolved, standardized. TCP/IP has standardized the packet switching and layer design. Everything we will understand this in detail. Okay, so don't worry about it. Then in 1984, DNS, that is human-readable domain names, came into picture. This is also a kind of a protocol. Then HTTP, which came in 1991. Then on the top of HTTP, there is this SSL 1995, which has came up. Then Wi-Fi, which we are nowadays using, right? Then IPv6, then HTTPS, and now QUIC. Okay, now these are not the only protocol. These are just a good milestone in it. There are many protocol which has emerged in between. There is a UDP which was emerged here somewhere. Then there is a HTTPS. But one thing I want you to tell you is these are not a standalone protocol. As they keep on emerging, right, they keep on using the previous protocols as is. Now HTTPS uses TCP inside it, TCP over SSL, right? So they keep on reusing the previous one and started integrating the new features and solving the new problems. Okay, now we will try to understand the TCP/IP story because that was the first protocol, first reliable protocol which has came into picture, right? So let us try with the TCP/IP story. So TCP/IP. So what it has solved? So initially before TCP/IP also there were a lot of innovation which was happening. Okay, people were not quiet. They were keep on innovating. So the only problem which they were facing is they were able to send the packets from one location to other, but they were not sure in which order. Whatever I send in this order 1, 2, 3, are they arriving it in 1, 2, 3? They were not sure. There were a incident where some packet used to miss second doesn't deliver at all. So the message which was getting delivered, right, it was like tampered. So TCP/IP came into picture and it has solved this problem. So TCP/IP makes sure that whatever you send in sequence 1, 2, 3, it should reach in 1, 2, 3 sequence only. You have sent 1, 2, 3, it should reach in 1, 2 and 3. This is the TCP/IP which has guaranteed it. Now how it has guaranteed it, right? So TCP/IP is using some acknowledgement kind of functionality. So for example, if you send 1, right, so your 1 will be sent here, and in case it is not received, right, it got tampered in the middle, then the second packet will not be delivered. TCP/IP will ask sender to send the 1 again. So this way it will make sure that the first packet will be delivered. Now second packet. Now if second packet is also getting tampered in the middle or some way, right, then TCP/IP again asks the sender to resend this second, and then only your third will be delivered. So every time, and once it is delivered, right, second is delivered, it will be acknowledged that it is delivered. It will be acknowledgement sent to the sender that it is delivered. So it's a to and fro, right? It's a to and fro. That way it has made sure that everything, whatever is sent, is delivered in sequence and as is format, right? Now if you see, right, there is some problem which was there, which was arrived in this kind of ways of communication. Okay, so what was that problem? The problem is every time you need to send a packet, you need to acknowledge it, right? So for every packet you have a to and fro motion, right? But this has added a overhead or slowness in the communication. Okay. And sometimes what is the thing is speed. Speed is more important. Speed is important, right? Instead of your communication, your speed of communication is also very important. So that's how the UDP come into picture. UDP try to solve this problem. UDP told that, okay, I will not send acknowledgement. I will just transfer the packages, but I will transfer it at a rapid pace. And that's how UDP got developed. Right? UDP is a user datagram protocol. So UDP is like sending a postcard. It's fast and simple, but there is no guarantee it will arrive or in what order. That guarantee UDP doesn't give. Now for what use cases UDP is good for? UDP is good for live video streaming. Okay, because in streaming, right, nobody will go back. In case some packet got missed, right, nobody was worried about it. People wanted to see what's coming up, right? As soon as I'm talking, you are not interested what had dropped in the past, right? So streaming application also make use of UDP. Then live video meeting application, right? Video chats, all these started using your UDP. Now, till this point, everything is okay. We were having TCP IP, which makes sure your message received intact, right? Message receives as is, right? Then we have UDP, which makes sure that message got delivered fast, right? It got delivered fast. But now this is fine. This is also a message, right? This is also a message. Now the thing is, as the technology evolves, right, there is another problem. Now what should be the format of this message? Okay, what should be the format of this message? Everybody try to put his own format. Like someone will put, for example, someone will put the sender address at the top, someone will send sender address at the bottom, somebody will add sender address in the email body itself, in the message body itself, right? So to standardize this, the application layer protocol came into picture. Application layer protocol. Okay. Application layer protocol, those are HTTP, Hypertext Transfer Protocol. FTP, this is another protocol. Then SMTP, okay, SMTP, which is email, which is getting used in email. Okay, each of these protocol define a standard way to request and send specific type of information. So they have defined the standard way of communication. So HTTP is using some headers. If you are aware, it has some header, sender header and all. Okay. So FTP also uses some kind of mechanism to define the information of the message in the specific format. And email and SMTP also you might be knowing. In email only we write a structure email, right? There is a to, then CC, right? So these all will be sent in a structure format. But this is how this has evolved. But there is one more problem which came into picture, which is security risk in this. There is a risk of security, right? There is not any protocol has handled this security risk. If your message is getting tampered in the middle or somebody is eavesdropping your message, you are sending message from here to here and somebody is reading your message in the middle. You don't have that provision to stop this, right? To address this next problem of security, HTTP was already a good protocol. There was not many problem in this HTTP, but only security. So security can be added into this protocol, right? So that's how the HTTPS came into picture. That is Hypertext Transfer Protocol Secure. This S stands for secure. So it has added security on the top of HTTP. So what it has done basically in HTTPS, so HTTPS, what it is doing is whatever messages you are sending, right? It is encrypting it. It is started encrypted it. Okay, it is encrypting the messages. Now, and the sender and receiver only knows the way to decrypt it. Now this guy who is eavesdropping in the middle, right? Who is intercepting, he doesn't have the key to decrypt it, right? So he is not able to decrypt it. So this was like a very big innovation in the network protocol. We will see how this has led to the innovation. What kind of application emerges from this. Now let us try to understand what all are the protocols and what problems it has solved. In one liner we will try to understand it. Okay, protocols and problems. Because whatever we discuss, those are not the only protocol. There are many protocols which has emerged in the middle. So let us try to understand those. Okay. So this is how our protocols look like. So we have seen initially the TCP has emerged. So TCP, what problem it has solved? Lack of universal communication standard it has solved. So initially we have seen the ARPANET used to communicate between the system in their local network, host to host communication they used to do. But how to communicate between the different network, that's how the TCP IP came to rescue, right? So what has improved? Reliable cross-platform data transmission. So anybody now able to see, any machine can able to communicate with the other machine. Okay. But what it has introduced is not ideal for real-time apps. So where real-time apps need to send the data very fast, right? It was the problematic because every time we have seen it has to send acknowledgement to and fro, right? Then UDP got emerged. UDP has tried to solve that problem. It has what problem it has solved? TCP was too slow for real-time needs. So that's how UDP introduced faster and low latency data delivery. But only thing, another problem which came into picture is no reliability or ordering. It has not guaranteed that your all packages, whatever we are sending, will be received and on what order, that guarantee is not there. Okay. Then HTTP. So messages we were transferring, but what is the format of the message? We were not sure about it. So to bring standardization in that, HTTP came into picture. So need for simple web document transfer. HTTP was addressed that problem. Then easy web access and sharing. Then statelessness, inefficient for dynamic data. So it has some problem. So statelessness means once it has sent the package, it doesn't remember anything about that package. That is the thing. Okay. Then next problem which has came into picture was security, right? So HTTPS try to introduce that security. Okay. So what it has done, it has encrypted your messages and then it was try to send it. But again, more processing overhead and certificate issue. It used to use certificate, SSL and TLS. It used to use these technologies to introduce the security. Then FTP protocol was there. FTP was helping in transferring the file between the computers. So file upload and download functionality is using this FTP. Okay. Again, there were some security risk in this. Then SMTP. SMTP is sending emails over network. So whatever application which send the emails, right, they follow the SMTP nowadays. Okay. Standardized email delivery. Okay. Then DNS. DNS is another protocol. Now, what problem it has solved is, now we are sending the packets from one system to another system. But how to recognize this system, right? I cannot name it is Yogesh system. This is Ganesh systems, right? It will not be. We cannot name it like randomly. So to bring standardization in it, the DNS, domain name system, came into picture. Then again, now since the machines keep on increasing, right? How to bring that many names into picture? How to address those many machines? So we need some system for that. So that's how the IPv6 came into picture. But before IPv6, there is a IPv4. So it used to give address to system like 10.10.2.4, 192.2.2.32, something like this. It used to give this way. But giving it in only 4 digits, right? 4 chunks, right? 10.10.2.4 is not sufficient because we have a lot of system coming up into picture, right? Nowadays, every device is addressed. So every device has an address. So if you are using a smartwatch, it is having its own address. So we need a provision to address these many devices. So IPv6 was needed. So IPv6 solved that problem. Then now recently QUIC. This is another protocol which is built on the top of HTTP/2. So HTTP/2 is an advanced version of HTTP. Okay. So HTTP we have seen, right? So it was used to encrypt the data, send it and all. So there were some latency which it tried to solve. We will understand it in further, right? So what are the problem it has solved. So this is how the different protocols. These are like a major protocols, right? People might ask you in interview, what are the major protocols? So these are the very major protocols exist as of today. And those are getting used also. Okay. Now let us try to understand what are the real-time problems all these protocols has solved. So let me put a different image here. Let us try to understand the protocol first, then what innovation it has enabled, example of application and everyday impact. You might be familiar with all these things, but let us try to understand it again. Okay, so HTTP. So whatever internet you see, right, the internet everybody is using, that is facilitated by HTTP only. HTTP, HTTPS. So since HTTP and HTTPS came into picture, right, your web browser and website concept has emerged. So you can make you have a bank website where you can do payment, right? That is possible because of HTTPS. Okay. So all the web browsers which you are using, those you can use because of HTTP protocol. Then SMTP and IMAP. Those are email communication, used for email communication. Whatever email communication application you use, right? Gmail, Outlook, Zoho, anything. Those use SMTP, IMAP and POP3 protocol. Okay. Then TCP/IP. TCP/IP which you use, right? So those are universal device connectivity. They introduce universal device connectivity. So all the devices which you are using, right? Smartwatch, your Wi-Fi connecting to multiple devices. All this is facilitated with TCP. Okay. Then FTP, SFTP. So FTP is a file transfer protocol. SFTP is a secure file transfer protocol. So you can upload the images, you can upload the files into Google Drive, Dropbox, FileZilla, etc. That is using FTP and SMTP protocol inside it. Then VoIP, internet voice and video calls. So whatever you are using, Zoom, Skype, WhatsApp calls, they are using VoIP. They can also use UDP. Okay. Then DNS. DNS is also a kind of protocol. So I have told, right, we were using IPv4, now IPv6, right? So in IPv6, every system will be assigned an address like this: AQRBCD dot BCDQRV something, AZBVDQ dot. So every system will be assigned an address like this, but this is not a understandable or readable format. So to give them a readable format, your DNS came into picture, domain name system. So they started mapping this address with some system, like this is okay. It is the Microsoft address, for example, Microsoft.com. So whatever you are seeing right now, this is also there is a rule for this. What name you can set, whether it's a .com, .in, .org, all this is coming in rules. Okay. So that is facilitated by DNS. So we have multiple DNS, Google DNS, Cloudflare DNS, etc. Then this is another protocol, MQTT or COAP. It is means for Internet of Things. Now as the devices, Internet of Things, this field is emerging, right? It needs lot of innovation to accommodate lot of different devices needs. Right now your washing machine can connect to Wi-Fi, right? It needs its own automation, home automations. So these protocols help into this. Then WebSocket. WebSocket is used for real-time web application communication, like online games and chat, where you can play online game, you can talk to the other player. So their instant messaging means in WhatsApp, you are sending message to other person and it will tick mark it and you will able to see that tick mark, right? That it is read. So how this is happening? It's happening because of WebSocket. Then LTE and 5G. It's used for mobile broadband. Now with the invention of mobile, right? Initially we used to use Nokia mobile. That time we used to only transfer text messages. Now we have a smartphone where you can transfer images, zip, videos, documents seamlessly, right? How that is possible? That is possible because of LTE, 5G, internet. Okay. Fast mobile internet video streaming on the go. Then another protocol is REST and gRPC. This has brought the innovation to cloud. Whatever cloud services we are seeing, right, it made possible because of this only thing, REST and gRPC. And microservices, whatever you are hearing microservices, right, those are possible because of REST and gRPC innovation. Okay, so these are some of the innovation which has brought by this protocol. Now, one last thing which I want to cover is what are the future trends now? What are the future is looks like for protocols, right? So the future of network protocol is continuously evolving. It needs a lot of innovation. Now you can see real-time gaming. Real-time gaming is happening. Okay, real-time gaming. Then automated cars. Self-driving car, right? Self-driving, auto car. Then we have virtual reality, right? This everything demands a protocol. So here 5G and QUIC. So QUIC is HTTP, if I am correct, HTTP plus UDP. This is the combination. So they have developed this to facilitate some of the use cases of this. Right, so these are some of the protocols which are evolving on the top of it, right? Then we have IoT, Internet of Things, like lot of things, small things are now getting connected to internet, right? Recently we have seen your glasses, smart glasses, which has launched by Meta, right? So that is also consuming now, that is also getting connected to internet. Now your washing machine, that is also connected now, refrigerator, right? All these devices are coming into picture. They also need the features which might need some extra enablement in the existing protocol. So that's how the protocol will emerge in the future. So there is a scope of innovation in the protocol. So if you have a better understanding of it, then you can also try to bring innovation into the protocol, right? So this is all about the network protocols, how those are evolved, and what are the innovation they brought into the life, and what are the applications, real-time applications which are using this protocol.